Good evening to all of you. Welcome to Gate Wallah. I hope you guys are fine. In the last class, we have discussed about chlorination. Chlorination, or maybe I think softening we have discussed. In the last class, we have discussed about softening. So till now, I think the first topic was Stokes' law. Second thing was chlorination, and the third thing was softening. These three topics we have covered. Any doubt from these topics? In the chat section, Himanshu is asking, sir, please tell one thing. Vijay batch, rank improvement batch, will full environment be covered? First of all, Himanshu, I just want to give you a small introduction about the Vijay batch. What is the purpose of Vijay batch? Vijay batch is for repeaters, those who have covered the whole syllabus and they got some rank, or maybe they have not qualified their best rank. So in that case, they want to go for a complete revision for the subject as well as practice for a few good questions. Questions which is generally not mentioned in the class, I will say, other than class notes. Those questions will be given for practice. At the same time, it will be a complete revision. You can ask your doubt, you can clear your queries. So that is what the purpose of Vijay batch, and ultimately you can improve your rank to your best abilities. Okay, so that is the purpose for. So if somebody who have not covered environmental engineering through comprehensive batch, in that case, that student will find difficulty while studying Vijay batch or while following the Vijay batch. Or if any student who is not having a proper class notes, that means after watching the comprehensive class, definitely you guys have made some class notes for the environmental engineering. If you don't have that, again, you will find difficulty in the Vijay batch. Is that clear? So if your doubt is clear, now we can start the today's discussion. Today and tomorrow, the topic which I am going to discuss will be related to the characteristics of sewage or characteristics of wastewater. So when we talk about characteristics, we have different type of characteristics. So let's start with the first one, which is the physical characteristics of the sewage. In the physical characteristics of sewage, the first thing is the color. For a fresh sewage, you will find the color is around yellow to light brown, and for the septic and stale sewage, the color will be dark brown to black. That generally occur because the degradation take place in a early stage when the sewage is fresh. Degradation has not started, or maybe even if it is started, it is in initial stage. So in that case, the color will be little bit yellow to light brown. But once the degradation phase is either completed or maybe at the last phase of the degradation, in that case, you will find dark brown to black color of the sewage. Now, what about odor? Fresh sewage will have musty odor, and the septic and stale sewage will have a complete foul smell, which is something which you don't want to smell it. When it comes to turbidity, fresh sewage will have the particle size will be large, so in that case the turbidity will be less. For a septic and stale sewage, because now the particles are smaller in size after degradation and all, after degradation and decomposition, that's why the turbidity increases. When it comes to temperature, initially the fresh sewage will have a temperature around 30 degrees Celsius. That means higher temperature. Septic and stale sewage, because what happens during the degradation process, during the decomposition process, these are endothermic process. So they will consume the heat for the reaction. And in that case, from where they will take the heat? They will take from the water itself. And that's why you will find from the wastewater, the temperature goes like near to 300 degrees Celsius. So definitely lower than 30 degrees Celsius. One more property I am writing it here will be the pH. Will be the pH. For a fresh sewage and septic and stale sewage, for a fresh sewage, you will find the pH level is 0 slightly greater than 7. Here I'm writing slightly greater than 7. For septic and stale sewage, the pH will be less than 7. Why I'm saying slightly greater than 7? Because what happens in the fresh sewage, one second. In a fresh sewage, generally what happens, some amount of sludge which is coming from kitchen sink, wash basin, basically when you're washing your hand, when you're washing the vegetables and all, that time the water which you are getting it, even when you are using the bathrooms for bathing purpose, in that case you use some soap or maybe shampoo, anything else, like most of these are alkaline product, and that increases the alkalinity of the water above 7, not very more, I will say not very much greater than 7, but slightly greater than 7. That is something which you can expect from fresh sewage. After degradation and all, again some acidic nature will develop, and because of that you will find the pH is less than 7. So that is about the pH. Now comes the second one, which is the chemical examination or chemical characteristics of sewage. Now in a chemical examination, or you say chemical characteristics of sewage, the first thing which we wanted to find it out will be the organic content. Second thing will be the inorganic content, and the third thing will be the dissolved gases in sewage. Now today I will talk about the organic content of sewage first. So in the organic content of sewage, multiple things are there. You have lipid, you have carbohydrates. These are things which are present in the wastewater. You have some protein, fats, multiple things are present. Now if you try to find out all the percentage, like composition of all these things, it is going to be very, very difficult for anyone to find out. Just wait for 1 second. Okay. So what I was saying, if you individually find out the composition of lipid, carbohydrates, protein, fats, and other things, it is going to be very, very problematic for us. For that reason, what we have done it, we said, okay, this organic content of the sewage, it is something which is going to degrade in the wastewater, and in the degradation process, they need some oxygen content for the degradation process, especially aerobic degradation. Now how much amount of oxygen they are gonna require or demand, based on that I'm going to find out the organic content of sewage. Are you getting my point? So we are actually finding out the organic content, but not directly. We are actually finding out the organic content, but not directly. Indirectly. Clear? So organic content of sewage, in that organic content of sewage, you will find that organic content will demand some oxygen, and that oxygen demand of wastewater is exerted by three class of material. One is the carbonaceous organic material, organic matter in a form of carbon. Second thing is oxidizable nitrogen derived from nitrite, ammonia, and other nitrogen compounds which serve as a food specific bacteria, nitrosomonas and nitrobacter. Basically nitrogen related, this is something which we are also calling it as nitrogenous oxygen demand. Then chemical reducing compound, which is Fe2 plus SO2 sulfide, which are oxidized by the dissolved oxygen. So these are the places where the oxygen demand of wastewater is exerted. This is the thing. Now based on that, we have given following are the different type of oxygen demand. First one is following are the different type of oxygen demand. The first one is, which we say, biochemical oxygen demand. Second thing we are calling it as chemical oxygen demand. Biochemical oxygen demand, chemical oxygen demand. Next one is the total oxygen demand. And the fourth one, which will be the theoretical oxygen demand. See, actually, the topic of discussion which I have set it for you guys, it is only this one, biochemical oxygen demand. But I wanted to give you an intro about all these. That's why I started with the physical characteristics of the wastewater. Actual topic of discussion for today's session is this biochemical oxygen demand. In short, you are calling this as BOD. In short, you are calling this as COD. In short, you are calling this as TOD. In short, you are calling it as theoretical oxygen demand. Clear? All these things are clear? Now I'm going for the actual topic of discussion. So till now, whatever I have discussed, this is just an introduction for all of you, so that all the students will be at the same level now. Now the topic of discussion is biochemical oxygen demand. Sometimes people used to call this as a biological oxygen demand, but that is not the right way to, I will say, put it as a term. It is actually biochemical oxygen demand. Now what is this biochemical oxygen demand? It is timed as, not timed as, it is termed as a measure of quantity of oxygen required for the oxidation of biodegradable, this point is important for us, organic matter present in a water sample by aerobic biochemical action. So in a simple word, if somebody will ask you, what is biochemical oxygen demand? It is basically the amount of oxygen required for the oxidation of biodegradable, only biodegradable organic matter. So in the organic matter also we have biodegradable organic matter and non-biodegradable organic matter. Here for the BOD we are only targeting about biodegradable organic matter. So whatever the amount of oxygen required for the oxidation of this biodegradable organic matter, and it is done by in a complete aerobic environment. So it is an aerobic biochemical reaction. So whatever the oxygen demanded, that is something what we are calling it as biochemical oxygen demand. A simple basic formula for the BOD. Simple basic formula for the BOD. Clear? Now there is a specific curve that we used to call this with a name as BOD curve. Now what this BOD curve is? In the y-axis you have BOD, in the x-axis you have time. In the y-axis you have BOD, in the x-axis you have time. Just wait for 1 second. Today my mouth is getting dry after every 1 or 2 minutes. So in the y-axis you have BOD, in the x-axis you have time. So y-axis BOD means y-axis basically it is the oxygen demand for you. Now what happens when the degradation start taking place, or I will say when the bacteria start doing their activity, we need to understand what type of bacteria we are using it and what type of organic matter we are having. In organic matter, the organic matter which we are targeting here, two type of organic matter you will find. One is the organic matter which is in form of carbon. That is something what we are calling it as carbonaceous oxygen demand, or I will say carbonaceous BOD. Second one is something which I will say related to nitrogen. So that is something what we are calling it as nitrogenous oxygen organic matter. So form of nitrogen, basically a form of nitrogen. Now in bacteria also we have two type of bacteria. One is something which we are calling it as autotrophic bacteria, another is the heterotrophic bacteria. Now what happens, there is a unique property of heterotrophic also, there is unique property for autotrophic also. What is the unique property in the heterotrophic bacteria? They need very less time to get adapt with the situation, with the environment, and they start doing their job as quickly as possible. And their priority, the first priority, or I will say they love to eat carbonaceous organic matter. They love to eat. For them it's like palak paneer or maybe butter chicken. The best food what they can think of. So they will first attack the carbonaceous organic matter. Carbonaceous organic matter. Simply a basic thing, if they will attack the carbonaceous organic matter, they will try to eat the carbonaceous organic matter. Definitely they need some oxygen for that. So you will find at the starting process, these heterotrophic bacteria, they started eating the carbonaceous organic matter, or I will say they started decomposing the carbonaceous organic matter, and then you will find this oxygen demand curve is also rising it. Because they are going to eat organic matter, in that case they will definitely demand the oxygen part. So this curve is rising up to a point. Then you will notice that these curve is getting flatter now. It is not rising like how it is rising here. It is getting flatter. Why it is getting flatter? Because generally, see, carbonaceous organic matter, the amount of carbonaceous organic matter will be limited. Now, it is not unlimited quantity. So after a time, you will notice this carbonaceous organic matter, the concentration is very less. So in that case, the demand is also not going to be rise. The demand is also not going to increase. A flatter demand here you will notice. Up to this it's okay. Up to this it is okay. Up to this whatever BOD you got, let's say from point O to A, that is what you are calling it as first stage of BOD. Sometimes you are also calling this as carbonaceous oxygen demand. That is clear now. Now what happens? Now the second bacteria, which is autotrophic bacteria. Autotrophic bacteria, they need few days. Sometimes it goes from 8 to 10 days, 8 to 14 days. So this much days, number of days they need to get adapted with the situation. Once they adopt the situation, once they are completely familiar with the situation, now they started doing the reproduction. Now they started doing the, I will say the degradation activity. And in that case, what happens? Till that time, all the carbonaceous organic matter is now gone. That is something which is completely degraded or decomposed by the heterotrophic bacteria. Now for them, the left part is what? Only the nitrogenous organic matter. So they will attack the nitrogenous organic matter, and they also need some oxygen for that. In that case, again you will find from A, again you will find this curve is rising. Again you will find this curve is rising. Now again, even nitrogenous organic matter is also limited, not unlimited. Limited quantity we have. So in that case, again this curve will go little bit flatter. So again this curve will become flatter. Now from O to A, whatever the oxygen demand you have, that is what we are calling it as first stage BOD, first stage biochemical oxygen demand. From A to C, it is what we are calling it as second stage BOD or nitrogenous oxygen demand, NOD, nitrogenous oxygen demand. Or sometimes people also call this as nitrogenous biochemical oxygen demand. Biochemical oxygen demand. Now from A to C is the total demand. A to C is the total demand in the BOD curve. Is that clear? Anybody having any doubt in the BOD curve, please let me know. Tell me quickly. Is this BOD curve is clear to all of you? Now the thing is that normally when you say BOD, we say BOD at 5 degrees Celsius and BOD at 5 days and 20 degrees Celsius. This is the standard one. Sometimes we also use BOD₅ and 27 degrees Celsius. But mostly in book you will find this is the standard one. Now for 5-day BOD and 20 degrees Celsius, for the 5-day BOD and 20 degrees Celsius if you talk about, why 5 days is required? Why not more than that? See, generally for the first stage BOD you need 8 to 10 days, 8 to 12 days. But what we have noticed in the 5 days BOD, almost 68 to 70% of the ultimate BOD is something which is achieved in that 5 day itself. So by the 5-day BOD data, at least I can say this much. I will say I can actually visualize or calculate the total BOD required, because if I have the 5-day data and I know roughly 68 to 70% will be the 68 to 70% of the total or ultimate BOD, that much you are going to get in the 5-day itself. So by that you can calculate the total one. More than 5-day waiting, it is actually not advisable, because see, already 5 day for a particular test is very long day na, like it's very 5 day, who like many of you will not wait for 5 day to get a test result, yes or no? So 5 day itself is very long. But why 5 day? Some people say that generally this concept is developed in the London, like in Britain area, where any river stream normally in a general level, then they actually take 5 days to ultimately go into the sea. So because of that they have selected 5. If somebody have selected 4.5, we have used that only. But now it is selected as a 5, so that becomes standard for us. And if you see theoretically also, so we are getting 68 to 70% of ultimate BOD in that 5 day. That is completely, I will say, enough to know about the oxygen demand for that wastewater. Ultimately for the organic matter concentration also. Now for 20 degrees Celsius if you talk about, see, we wanted to take a temperature which is realistic to the situation, especially in the natural stream. Now if you take higher temperature, generally what happens in a natural stream, you will not find higher temperature throughout the day or throughout the year. So taking higher is again not advisable. Taking lower is also not advisable. At the same time, we wanted to give some temperature, enough temperature, so that the bacterial growth will be decent enough. See, if bacterial growth will not be decent enough, in that case, all this discussion will be invalid for you. Basically, if your BOD if you are finding for the very, very low temperature, the rate of decay is something very, very low for that. As you also know that it depends on the temperature. So all these discussion we actually analyzed, or all these points we have analyzed, and ultimately we come up with 20 degrees Celsius, because first of all, it supports the bacterial growth. This temperature supports the bacterial growth. At the same time, this temperature actually resembles the outside natural stream temperature, the average temperature also. So by that logic, we have selected 20 degrees Celsius. Again, now if somebody will say, sir, why not 21? Why not 22 degrees Celsius? See, that I don't have any answers. After discussion, they have selected 20 degrees Celsius, so we are taking that. If after discussion they have selected 22 or 20.5, we have used that also. So the logic that we understood, and why 20 is selected, that is something which is understood for all of you. Clear? Now, these 2 points, if you all have understood, now what they are writing it here, I want you guys to simply read this once quickly. Already I have discussed this, but I want you to read it once. Okay. Now, all this discussion which we had, I have already written here, so you guys can read it once whenever you get the notes. Now the next discussion is, sir, how to find out BOD. Two type of method we have used to find out BOD. The first one is the experimental method, and the second one will be the analytical method. So today I will discuss the experimental method first, and then if time permits, I will go for analytical method. So this is the BOD bottle that we use for the test. General volume for this BOD bottle, very bad diagram. So initially I have taken VS. Initially I have taken VS volume of sample. Now this is a BOD bottle. The total volume of BOD bottle is generally 300. Now what happens if this is the volume of sample, and if I want to find out the BOD for this, or BOD for this sample, the main issue will be, see, what is BOD actually? It is the amount of oxygen demanded by the organic matter. Now in the sample which we have taken VS, In that sample, the volume is Vs, and what is the dissolved oxygen for this sample is DOS, or sometimes we write DOW. W means waste, S means sewage basically. Now, as you know, in the sewage, the dissolved oxygen concentration is very less. Now, if already you know that the dissolved oxygen concentration is very less, how can you find out how much oxygen is demanded by the microorganism? It is like in someone home, if there is no chance of any chapati or roti, then how can you ask that person how much you can eat? Unless that person is not having the chapati or roti to show you. Basic thing. So if in that sample, you wanted to find out the BOD, the oxygen demand, but actually in this sample, the dissolved oxygen of that sample is very, very less. So what is the ultimate thing which you can do? What we will do here, we add some distilled water through this. We add some distilled water and we'll fill this area up to this. The complete area we have filled with the distilled water. With the distilled water. Now it is not a normal distilled water. This distilled water will be having volume Vd. At the same time, the dissolved oxygen will be very high because we have aerated this water. We have aerated this water before adding into the BOD bottle. So this water is having enough, I will say more than enough oxygen content, but this water is distilled water, so you don't have any solid content in it. You don't have any solid, either organic or inorganic, no content is there in that water. It is only distilled aerated water or aerated distilled water, like this you can use. Now, why we are adding this water? Now this water will give you enough oxygen, because if you add water, this wastewater sample is gonna be mixed completely. Even sometime we do this shaking type of thing so that the wastewater sample and the distilled water sample gets completely mixed up. Now this wastewater sample is having enough organic matter, and now this wastewater organic matter will have enough oxygen also to consume. And then I can find out how much oxygen is consumed, and that oxygen consumed is basically the BOD of that sample. That is the logic, that is the basic procedure which I am going to do in this test. Now what happens? First of all the data which I have used, so I am writing it here. So Vd, as I said, it is a volume of distilled aerated water. DOD is the dissolved oxygen of distilled aerated water. Distilled aerated water. Vs is the volume of sewage sample. And DOS is nothing but the dissolved oxygen of sewage sample. Dissolved oxygen of sewage sample. If you mix these two, that is something which I am writing it as DO mix. If you add these two, it will become, it's better to write this with a different color so that it will be clearly visible to all of you. So DO mix is something I'm writing it as Vd into DOD plus Vs into DOS plus Vd plus Vs. This is what I'm having. So you have Vd DOD plus Vs DOS divided by Vd plus Vs divided by Vd plus Vs. Clear? Clear to all of you? So DO mix you are having Vd bracket DOD plus Vs DOS plus Vd plus Vs. By that you will get the DO mix for the sample. DO mix for the diluted sample. Now what we do? Now we'll put this mixture, this complete mixture, into BOD incubator and we'll set the temperature of 20 degrees Celsius and the time will be 5 day. Time will be 5 day. So after 5 day, if you take out, after 5 day, if you take out the BOD bottle and then you test the dissolved oxygen of that sample, that will be called as DOF, that is dissolved oxygen of diluted sewage sample after 5 days at 20 degrees Celsius. If you have done it for 5 day, then it will be after 5 day. If you have done it for some other day like 3 day or 4 day, in that case you can take that much number of days. Now if you want to write BOD formula for this situation, let's say you want to write for BOD₅ at 20 degrees Celsius, so the general formula will become what? See, initially you are having DO mix. Initially you are having DO mix minus, after 5 days you are having dissolved oxygen for that sample, that is dissolved oxygen final. The difference will give you how much amount of oxygen which is utilized during that 5 day of degradation process at 20 degrees Celsius. If you have set it for 20 degrees Celsius, if somebody have set for some other temperature, in that case that temperature you have to mention it. Like for example, if somebody have set it for, instead of 5 days, if somebody have set it for 3 days, so that person will put 3 here, and somebody have set it for 27 degrees Celsius, so you have to write 27 degrees Celsius BOD. So this DO initial minus DO final. First of all, DO initial is nothing but, the DO mix. If you want, I can write it here. It is nothing but DO initial for you. Okay. And the DO final is something which you will measure after taking out that sample from the BOD incubator. Now, this difference will give you the BOD of sample or BOD of diluted sample. That is what my question is to all of you. You all have seen, you all have observed the complete experimental discussion. Now you guys will tell me, this BOD which you got, it is for the sample or it is for the diluted sample? This BOD is for diluted sample or for original sample? Simple thing, my dear. The DO initial which you have taken, it is not for the original sample. It is for the diluted sample. It is for the diluted sample. So obvious thing is that the BOD₅ 20 degrees Celsius, right now what you are getting, it is the BOD for that, I will say it is the BOD of diluted sample. You want to find out BOD for original sample. So for that reason, what you are doing it, you are multiplying with the dilution factor. Dilution factor, in a short, it is DF. And that become a formula for us. That is what it become a formula for us. Clear? Now, when it comes to dilution factor, it is 300 divided by Vs equal to 100 divided by percentage dilution. It is 300 divided by Vs or equal to 100 divided by percentage dilution. 100 divided by percentage dilution. So dilution factor, the basic meaning of dilution factor is what? Final volume upon initial volume. So initially the volume of sample is Vs. After dilution it becomes 300 because 300 is the volume of the BOD bottle. So that's why I'm writing 300 divided by Vs. So either you can use this formula, or maybe if you want to talk in percentage, so it will be 100, total percentage will be 100 divided by the how much percentage dilution. So 100 divided by the percentage dilution. So this is the formula which you have developed through experimental method. Through experimental method. Anyone having any doubt in this discussion? Any of you having any doubt in this discussion? Okay, so if nobody is having any doubt, then you can answer this question quickly. If nobody is having any doubt, in that case, you guys can answer this question. Answer this question. Wastewater sample diluted to 100 times with aerated water had initial dissolved oxygen concentration as 7 milligram per liter. After 5 days of incubation at 20 degrees Celsius, the DO was found to be 0. Now, this is something which is very important for you to understand. If after 5 days, if you take out the BOD bottle and then you have calculated, then you have measured the dissolved oxygen level in that BOD bottle, and you found the dissolved oxygen value is 0, that means you cannot actually you can give an idea about after how many days that DO of that sample becomes 0? Is it after 3 day? Or is it after 2.5 day? Is it after 4 day? Is it after 4.5 day? Is it in the first day itself the dissolved oxygen concentration becomes 0? So you don't have any clear idea, na? So because you are getting you are measuring data only after 5 day, once you take out the BOD bottle from that BOD incubator, then only you have measured it. So in that case, this data will be irrelevant for you. In that case, with this data, you will not be able to find out the BOD value. So the right answer for this question will be D, cannot be determined. So never, always remember, DO final can never be 0. It is not something which is allowed. DO final in the BOD test, you cannot get 0. So, sir, then what should I do next if I get 0? In the test, if I get the 0 value, that means you need to dilute this wastewater sample in a much higher way, so that this water will have enough oxygen that even after degradation for the next 5 days, this water will have some oxygen to show you after 5 days also. You have to increase the dilution. You have to increase the dilution. The diluted, that water which you are using for the dilution purpose, you have to aerate it more, so that the dissolved oxygen concentration in that distilled aerated water will be more. Or you can change the dilution ratio. That also you can do. Am I clear to all of you, my dear? Go to the next question. Try this question. I think they have used the previous question options. So options are not right. Options are not right. So what is given in this question? 2% dilution of seaway sample. 2% dilution means what? They have given you the dilution factor, which is 100 divided by 2% dilution. That means 50. Okay. Is incubated for 5 days at 20 degrees Celsius. The depletion of oxygen was found to be 4 ppm. Then what they want from you is the BOD for 5 days and at 20 degrees Celsius. Am I right? They have already given you the depletion part, means they have given you the DO initial minus DO final. This value itself they have given you, which is 4, na? Which is 4 ppm. So 4 into dilution factor is 50. So your answer for this question will be 200 milligram per liter. That will be the BOD₅ at 20 degrees Celsius. Try the next question. Or it's better try this one. Try this one. Now in this question, they have given you DO of aerated water. That means they have given you DOD. DO of diluted sample after 5 days. That means it is DO final. DO of original sample. That means DOS. So to find out BOD of the sample, the first thing you need is the what? You need DO mix. Am I right? Or which you are also calling it as DO initial. It will be DOD. The formula is DOD into VD, DOS into VS divided by VD plus VS. So when it comes to VD plus VS, okay, so DOD DO of aerated water is 4. VD 4% dilution of sample, so that means diluted will be 96. DO of seaway sample is 0.5 and the volume of sample I am considering as 4 unit divided by VD plus VR. As I'm talking all these values in percentage, so that's why I've written 100. Okay, direct volume is not given to you, so that's why I have used that percentage of dilution part. So how much you will get it after solving this? According to my calculation, I am getting around 3.86 milligram per liter. This is what the DO initial I am having. Okay. Now once you got the DO initial part, then we can go for BOD value. Then we can go for BOD value. Formula is very clear. DO initial minus DO final into dilution factor. So DO initial is 3.86. DO final is something which is given to you 0.6. So 3.86 minus 0.6 into dilution factor is 100 upon 4. So how much will be the BOD value for you? How much will be the BOD value for you? I'm getting around 81.5 milligram per liter. 81.5 milligram per liter. I think this is clear to all of you. Okay. Now, if you understood this part, then in the experimental procedure itself, sometime what happens, the water which you are using it for dilution, that water is also having some microorganism content. That is something which we are calling it as seeded water. Sometimes seeded water is used for dilution in the BOD test. The seeded water is the water with seeding of mixed bacterial culture. Sometimes we do this also. So in that case, the formula will have some small changes in notation also and in the values also. BOD is something which you have find it out. D1 minus D2, it is the same. DO initial minus DO final. That is the same. Only 1 and 2 we are using it. Only the numbering change. Minus B1 minus B2. B1 minus B2 is the basically, even in the seeded water, you will find the change in the dissolved oxygen. So that also we are calculating it. So that is B1 minus B2 into 1 minus P. P is the dilution ratio here. P is the dilution ratio here. So 1 minus P divided by P. Now let me introduce all the terms for you. DO of diluted sample immediately after dilution. So this is similar to DO initial for you that we have already. DO of diluted sample after 5 days. This is similar to DO final what we have. DO of seeded control sample before incubation, DO of seeded control sample after 5-day incubation. So that is B1 minus B2. That is B1 minus B2. And the P is the, as you can see here, volume of undiluted sample divided by volume of diluted sample. So is it not looking like 1 upon dilution factor? It is not looking like 1 upon dilution factor? Hi, Anna. Yes or no? So dilution factor was volume of diluted sample divided by volume of undiluted sample. Final volume upon initial volume. That was the logic behind the dilution factor. And this P is reciprocal of that. P is reciprocal of that. Volume of undiluted sample divided by volume of diluted sample. So it is, P is something which we are denoting as decimal volumetric fraction of sample used. Decimal volumetric fraction of sample use. So all these terms are not new for you. The same term we are using it, but with different symbol. With a different symbol. Only B1 and B2 is something which is different here in the seeded water. So this formula also you need to remember it. Maybe in future, in some part of, in some exam, you will find this type of question they are asking from this. Okay. Now for today's discussion, I think this much is enough. Tomorrow again we'll meet, and the topic, the same topic I will continue. So in the BOD, the analytical BOD first I will discuss. Today I will discuss the experimental BOD with you. I have also discussed the basic introduction and the basic concepts which is related to the BOD. So I'm hoping that the BOD as a concept you guys are very clear about now. Experimental based questions you can practice, but like one question if you want I can give you as a homework also if you want to try. So one question I have which is based on experimental method, this one. So this problem you guys can try as a homework. Okay. So tomorrow we'll complete this physical part. Tomorrow we'll complete this characteristics part. Tomorrow we'll discuss the COD also. So tomorrow class is again going to be interesting for all of you. First analytical BOD method I will discuss, and then the COD. These two things I will discuss tomorrow. Okay, so that bye-bye, take care all of you. For any query or any doubt or any guidance related to exam if you want to discuss with me, this is the Telegram group for you. Mrigank sir PW. Mrigank Mrigank sir PW. In this Telegram you can join. For even if you have any doubt in the class itself, you can later on ask your doubt in the chat section. Or if you want to check, if you want me to check your homework question solution, in that case again you can send me that solution in the Telegram group. I will check and I will reply and I will give you whatever required feedback. Okay, so that is the thing for today. Bye bye, take care. We'll again meet tomorrow at the same time 6 PM. Till then, take care. Bye bye. Jai Hind.